Hey guys, this is your friendly neighborhood pre-cal teacher one more time. I want to talk to you guys now about the third part of vectors. This should help you complete the assignment that you have currently that's not due, of course, until after spring break. It would have been due Tuesday, but Tuesday is a holiday, so it's due next Tuesday. And it deals with component form of a vector. But first thing we're going to do today, I'm going to give you a little bit of review of what we've dealt with so far in the other two videos. I do want to talk about what component form is of a vector. And then I want to do some of the things that we've done before, because we've talked about magnitude and direction. We've talked about addition and subtraction. So we'll do that with components as well. Remember, vectors have to have magnitude, have to have a direction. They have to have both of those. If they don't have both, they're not a vector, right? If they just have magnitude, if it's just 5 feet, then it's not a vector. If it just has a direction, if it just says north, it's not a vector. It has to be a combination of the two, 500 miles an hour northwest, okay? The direction can be shown in 3 different ways. We talked about a direction angle. We talked about a bearing, and we talked about map bearings. Those 3, of course, you'll see. So then we talked about adding and subtracting vectors to get what's called the resultant. And that's the result of your trip. So all of those were in the first 2 videos. If you have any questions about those, just go back, look at those videos. And if you still have questions, email me, or when we do the live session, you will know what you need to ask. Okay? Now I do want to talk about this thing called component form of a vector. And in my opinion, again, as humble as it may be, and most of the time it's not, because I'm not very humble, component form is probably the easiest way to deal with vectors. But in order to do component form, we have to have a coordinate plane. So notice I don't have an x-axis and I don't have a y-axis. Why don't I have that? I don't have that because, of course, vectors, while they have magnitude and direction, vectors do not have a specific location. So since we're talking about vectors, we don't need to know where we are on the grid. We just need to know the magnitude and the direction. So let's put some vectors on here. So I'm going to insert some shapes, and let's make the shapes in the form of an arrow. Okay, let's put this one here. Let's come over here and put, let's insert another one. Let's have this one go that way. All right, so we have 2 vectors. We'll call this one vector A. We'll call this one vector B. And with component form, you notice they're vectors, they're directional. Components are just talk about how the vectors move along the grid. So if we're looking at this vector, how far does this vector go over? It goes over 1, 2, 3, 4, 5, 6, and it goes up 2. So vector A in component form is 6, 2. Over 6, up 2. Vector B, on the other hand, goes over 2 and goes down 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. But since they're both in the negative direction, vector B goes backwards 2 and down 8. So there you go. There's our 2 vectors. Components talk about how they move on the coordinate plane. So now, let's say we wanted to add these vectors. Remember, we add them by moving tip to tail. So I'm going to go up a little. I'm going to take this vector, and I'm going to move it over here. And I'm going to take this vector, and I'm going to move it down here. So now I have my vectors going tip to tail. And I can draw the resultant. So let's draw the resultant there in red. Let's draw the resultant purple. The resultant starts here and goes there. So the resultant goes over 1, 2, 3, 4 and goes down 1, 2, 3, 4, 5, 6. So -6. So the resultant is 4, -6. So you can see that because it's on the coordinate plane. Now, what's really neat about component form is if you're adding and subtracting vectors, remember we have vector A plus vector B. A was 6, 2. B was -2, -8. And when we added them, the resultant was 4, -6. That's the resultant. Now, some of you have already noticed, but some of you haven't. Check this out. This is the best thing. What is 6 plus -2? Well, 6 plus -2 is 4. 2 plus -8 is -6. So if we just add the components, we get the resultant. So how does that help us? What does that mean? Okay, let's go with another. Well, let's erase all of this. So let's select this. Let's do select all and backspace. So let's say we wanted to add vectors A or C, because I'm tired of A and B, which is 2, -5, and vector K, which is 3, 9. So if we wanted to do vector C plus K, we wanted to do the resultant of that, that's going to equal 2 plus 3 and -5 plus 9. So C plus K is going to be 2 plus 3 is 5, -5 plus 9 is 4, if we add those two vectors. Okay? If we subtracted the vectors and we went C minus K, you can do the same thing. 2 minus 3 is -1. -5 minus 9 is -14. Because remember, we subtract by going in the opposite direction. So now we have components, we've added them, and we've subtracted them. And the last thing we wanted to do was look at components, look at the magnitude and the direction of the components. And again, because it's in component form, magnitude and direction, I think is that much easier. So let's still take, let's take some of this stuff off where we added and subtracted them. And let's look at vector C and vector K. Well, vector C, we're going to draw it. We have 2, -5, so I'm not going to draw it with that. I'm going to insert a shape, which is going to be a vector arrow. And I'm going to make it go over 2 and down 1, 2, 3, 4, 5. That's vector C. And vector K, let's take that and copy it and paste it. Vector K would go over 3, 1, 2, 3, and up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So those are our two vectors. That's vector C and vector K. How do we determine the magnitude of those vectors? Well, the best thing about it is these vectors now are in the coordinate plane, and because they're in the coordinate plane, we can find the distance between 2 points. Or we can do the Pythagorean theorem. So how far did this go over? 2 went down 5. That makes it a right triangle. So the hypotenuse of the right triangle is the square root of 2 squared plus 5, or negative 5 squared, which is the square root of 4 plus 25, which is the square root of 29. So that's how we find the magnitude of a vector in component form. So the magnitude here would be, goes over 3, so it's the square root of 3 squared plus 9 squared, which would equal the square root of 9 plus 81. So this magnitude is the square root of 90. Okay, so that's how you find the magnitude of a vector in component form. So now we have component form. We can add them by adding the components. We find the magnitude by doing the Pythagorean theorem. So let's see. Let's clear all of this. Select, Control A, backspace. Okay. And I just want to make sure we have it before we end this video. I'm going to say we have vector P, which is, notice the brackets and not the parentheses. Parentheses make it an ordered pair. The bracket makes it a vector. So we're going to say P is negative 2, 6. We're going to say vector R is 1, negative 9. And I want to add them, I want to subtract them, and I want to find the magnitudes. Okay? To add them, of course, we add the components. So this would be negative 2 plus 1 and 6 plus negative 9. And there I go again with messing up the thing. 6 plus negative 9. And the sum is, the sum is negative 2 plus, negative 2 plus 6. The sum is 4 and negative 8. If we're subtracting them, we subtract it, so we go negative 2 minus 1 and 6 minus negative 9, and we get, so this is the sum. The difference would be negative 3 and positive 15. And then the magnitudes are simple in that the magnitude of P would be the square root of 4 plus 36, which equals the square root of 40. And R would be the square root of 1. 1 squared is 1, plus 81. Negative 9 squared is 81. So it would be the square root of 82. Okay, so vectors in component form, over and up, just like points, it's movement. You can add them by adding the components. You subtract them by subtracting the components. To find the magnitude by doing the Pythagorean theorem with the components. Everything works with those numbers. All right? Thank you.